Okay, if you are just joining us, we are talking about the geometric sequences, and we've been talking about series and sequences for the last week now, but we've only been looking at arithmetic sequences, the sequence in which the term can be derived by adding or subtracting from the previous term. So today we're going to look at geometric sequences. A good kind of definition to get us going is a geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero constant. So a key word in there is actually by multiplying it by a non-zero constant. You might ask yourself, well, can't you divide it as well? And the easy answer for that, of course, is yes. But think about it. Dividing by 2 is the same thing as multiplying by 1/2. So to keep it routine and kind of some continuity to it, we just say that it's multiplying by some sort of ratio. So let's take a look at a geometric sequence. Below we have 2, 10, 50, and 250. This is a geometric sequence, but what is the reason for that? Well, if you take a look, to get from one term to the next, you'd actually have to multiply it by 5. From 2 to 10, you'd multiply by 5. From 10 to 50, multiply by 5. So each term can be derived from the previous one by just multiplying it by 5. Here's something that you should note, however. If you actually take a look at each one of these ratios, so the ratio of term 1 and term 2, you would get 10 over 2 or 2 over 10. Either way, you'll get a ratio of 5 or 1/5. If you take a look at term 3 and 2, you get the exact same ratio. So in term 1, you have 2 and a 10 for term 1, 2. Then you have a 50 and a 10. Then you have 250 and 50. Each one of those produces a ratio that is identical, even if you turn the numbers the other way around. So looking at the ratios between the next term and the term that you're looking at, so term 2 divided by term 1, will give you some sort of common ratio. In this case, it's 5. But how about an algebraic definition? Well, here we can look at the nth term, un, is the nth term. It's geometric if and only if you take the nth term plus 1 and divide it by the nth term, you'll get r, where r is a constant common ratio. So take, for example, term number 2 divided by term number 1, and you'll get r. If you take term number 3 divided by term number 2, you would also get that same r value. Let's take a look how we can derive the general geometric formula. So suppose the first term in a geometric sequence is the u1, which is the first term. Now it's irrelevant what that number actually is, because we're just trying to find a formula for the general statement as opposed to a specific statement. So if the first term is u1 and the common ratio is r, then we can say that u2 divided by u1 equals r, since it's that common ratio that we were just previously explaining. And rearranging the formula a little bit, we can make it say the second term equals the first term times the constant r. And then we can go on to say that the third term can be found by taking the first term, multiplying it by r once to get the second one, and then once more to get to the third one. So it's the first term times r, or the first term times r squared. In fact, you might see how this theme goes on for each consecutive term. So you have the fourth term, which is the first term times r times r times r, or the first term times r cubed. So it would seem that in general, if you wanted to find the nth term, all you have to do is take the first term and multiply it by the constant to the power of whatever term it is minus 1. And this, in fact, is the geometric sequence formula, so that you would want to write this one down for sure.